nonprofit. And then we have the mission of adding her story to history to tell our story. And we're located in Baltimore City, although we're statewide, our location happens to be there. We're at 333 North Charles Street, which is in the former Women's Industrial Exchange building. So we're in a historic building. That's a perfect location for us. In addition to our exhibits that we have there, and we have an exhibit of women in STEM, women in the arts, the suffrage, unsung heroines, and the Maryland Women's Hall of Fame. So at some point, although our exhibits are portable, right now, because of the current situation, we're offering primarily virtual programming like today. What I would like to invite you to do, as we have a few more people coming in here, we'd like to invite you to check out our website, where that's ongoing. It talks about our programs. You can register, you can get on our mailing list, but there's a lot of information about Maryland women that are there. So I hope that you'll check that out. And then we're thrilled today to host the Queens of Code. And I met Eileen a couple of years ago when they were just getting started with their project.
Hi. Okay.
And it was an opportunity for the Women's Heritage Center to partner with them as we do many other.
Okay. All right. Thank you very much.
Please be sure you're on mute. Thank you. It's an opportunity that Eileen and I have been talking about for years, to have a program such as this. So we're finally having it. But I also wanted to mention that in the last 2 years, two of the queens, one was Dr. Nancy Welker, was inducted last year into the Maryland Women's Hall of Fame. And Dottie, I'm blanking on her name for a moment. I'm so sorry.
Dottie Bloom.
Thank you very much. Was just inducted. We were notified last week. So they, among the queens, have some very special women. So I want to thank Eileen for being here and have some of her friends that are here today. And I wanted to let our guests know that you'll have an opportunity to only write in the chat box because we have so many people here today. But please write your questions in the chat box and then we'll deal with those at the end of the panel. So with that, I'd like to turn it over to Eileen. And Eileen, as the Queen of Codes, please take it away.
Well, thank you. Thank everybody for coming in. I know that there are a lot of people in our audience who we worked with many years ago, and also people who have been here with the Maryland Heritage Center. And also I'd like to welcome in the people who are coming from the simulcast, which is going around the world with the Internet Society. So that's really exciting for us. I'm going to share the screen now, and yeah, let's see if this will work, and I'll show you my slides. Share. Okay, are people seeing my slides now?
I don't know what my name's.
Oh wait, you are sharing. Can you see the slides now? The first slide?
Yes.
Okay.
Recording in progress.
Okay, good. Oh, I'm glad we're recording this too. Okay. So we're delighted to be here with you today to talk about our Queens of Code project, which is telling the story of NSA's computing women. And we appreciate the support of the Maryland Heritage Center, who's been working with us for a couple of years. And they, as Diana said, they help other Maryland women tell their stories. Well, we've kept our secrets for 50 years or more. And if we didn't share them now, they might have been lost forever and no one would have told these stories. And today we'll be speaking about our experiences working with computing and technology at NSA in the early days in the 60s, 70s, and 80s. And we'll also be giving tips to students who are thinking about careers in STEM. If there are students that are attending this, or we encourage you to ask.
For bagging, thank you.
We encourage you, the students, to ask questions in the chat room, and we'll try to get to them, because one of the reasons that we're doing this is an outreach to students. As Diana mentioned, we are really excited that we have two women that are going to be now in Maryland's Women's Hall of Fame. Dr. Nancy Welker, who might be in this audience today too, and Dottie Bloom.
I have.
Dottie was one of the most influential women in computing in the early years, and she was a technology leader at NSA, and she was a mentor to many of our women and men, including our Queens of Code. And Nancy was NSA's first female chief of the Research and Development Organization, and is a groundbreaking physicist who worked on superconductivity with mainframe computers and also created NSA's microcomputer lab. I'd like to have a special thanks to all the women who've been part of this project. Telling their stories was not an easy task. First of all, we had to remember what happened 50 or 60, 70 years ago, write them down. And then we had a really long and challenging process to get everything approved through NSA's pre-publication review before we could share them.
Sound.
I don't know about you,
It's
but
being
sometimes I
recorded.
can't remember what I had for breakfast in the morning, but thankfully these women came through. So today we're going to do some time traveling. We're going to go back to our pre-Queen days in the 50s and 60s, in the early days of computing. So slip into your bell-bottom pants and your paisley print shirts, hum a Beatles tune if you can keep on tune, and buckle up for the journey. For those who didn't live in the 50s
How
and
can I get it
60s,
on my screen for my video?
is there a question?
How can I change my video here? Can I change the screen to be able to pull up the video? Audio, I mean?
You're interrupting things, lady.
And Angela, please mute. I'm muting all.
Yeah, if anybody has questions, please just put it in the chat room and Diana will try to address them. Okay. For those who didn't live in the 50s and 60s, I want you to think about a world with no Google, no iPads, no PC, no pocket calculators, no ebooks, no email, no online shopping, and not much in the way of technology as we know it today. But at NSA, by 1968, we did have over 100 computers. And there were around 150 women who were Queens of Code, who worked in many areas of technology. They made up about 10% of the technical workforce. And we were recruited by the agency from some of the best schools in the country. And actually, many of us were recruited during the heart of the Vietnam War, when it was really, the Defense Department and military were not really welcomed on college campuses. So it was kind of odd that our advisors prompted us to go take these interviews with NSA. But some of our women majored in math and physics and other humanities. And we also had some of the first computer science undergraduate and master's degree recipients in the country. So talking about our project, why does our history matter? You know, why did we bring this to light or wanted to bring it to light? Only a few women have been recognized in computer history. Most history, which is his story, says that women only held data entry jobs back then, but that was not the case with computing women at NSA. Books about computer development and computer museums portray IT as a boys-only club, and we want to set the record straight. Some that say this is because women wrote the code and men wrote the history. But at NSA, actually, women and men wrote the code and nobody wrote the history because everything was classified. Our stories are about everyday events. However, we were supporting systems and writing code for applications and operating systems, planning for IT, managing big projects, multi-million-dollar projects, even back then, doing cutting-edge research and development, creating new technology, and much more. Our systems had to run 24/7 because we were providing life and death support to the men and women in the field, as well as to key decision makers like the president and Congress and our government. They depended on us. They depended on our systems. Along the way, we fought for women's rights and fair promotions, childcare, maternity benefits, flexible work schedules, work from home and part-time that made the workforce more friendly to women. And one of the reasons we're coming out now and doing speeches and writing articles, and hopefully we're going to have a film coming out soon from the Cryptologic Museum, is that we want to be role models for young women today and encourage them to pursue STEM careers. We tell young women, especially today, if your grandmothers and great aunts could have 50 years of rewarding and fun careers in tech, so can you. If you work hard and take the challenging courses, we don't promise that it's easy, but it is very worthwhile. And then we have a message for companies who struggle and recruit to retrain the women. You know, looking at our stories of how the agency recruited and trained and had opportunities for advancement, that some of these companies could learn a little bit from our experience. Now, the actual project came out was when I worked at NSA, I was fortunate to work with smart and talented and amazing women. We worked on projects and teams and cross-agency working groups. We were a cadre of technical expertise that had a big impact on our organizations and NSA's mission. And we worked alongside the men. We were about 10% of the workforce, but we were an integral part of the technical cadre. As an aspiring writer, I felt we had a story to tell, but back then it was really hard to think about with all the security things and being able to write about it. Back in 2018, I went to the Computer Museum in San Francisco with my family, and it was really fun to see all the old computers that we worked with there and all the stories about all the men who'd worked on computers, but they're really, other than Grace Hopper and Ada Lovelace, there were no women in this museum. And I came back feeling like, well, you know, there was something wrong with that picture. And I talked to friends and coworkers in the Cryptologic Museum and History Department, and even Liza Mundy, who did Code Girls, and everybody encouraged me to try to pull this together. So that's kind of how the project started. Now, a career in technology, especially the agency, meant a lot of different things. It meant making a difference to how things got done. And that's technology is that for anybody who's working in that field today. There are millions of jobs, both now and in the next 10 years, and well-paying jobs too. In fact, if you just looked at the new jobs report that came out from US News and World Report last week, the #1 job in the whole country is in information security analyst, and that's in the field of cybersecurity, which is one of the areas that we would like to promote. And the 10-year outlook is really good in these areas. And there are a couple other IT jobs on the top 10 list too. And I'll tell you a little bit about my background. I was born in Georgia, and I grew up in a small town called Warner Robins. I met my husband at Ohio State. He was also a computer science major, and we've been computing together for more than 50 years. And back when we actually graduated with we were the first graduating class in computer science from Ohio State. And when we were interviewing for jobs, and we got a lot of offers around the country, most companies offered me 25% lower starting salary than they did my husband. But NSA was different. They offered me the same starting salary as the men, which I thought was quite remarkable for that time. And what I liked about a career in computing at NSA was something exciting was happening almost every day. And I had an opportunity to solve problems and contribute to our national defense. I have one little story to tell you from when I was growing up. I think it shows that, you know, today smart girls have a tough time. And I think when we were growing up as smart girls, we probably had a tough time too, because the girls were really encouraged to show that they were smart. They were, here I was actually named in middle school, named most intellectual, but it was not a superlative that was that you really aimed for. You really wanted to be most popular, most likely to succeed, but I was most intellectual. But in 8th grade, we had an eccentric teacher named Mr. B. And for our spring quarter grade, he decided it would be based on how well we did at building and flying a kite. While I was not thrilled that, all the work we'd done so far on papers and tests, not counting, because I already had an A in the class, I got into the spirit of this competition when he assigned us to 2-person teams. My teammate Nancy and I had never built or flown a kite, but both being smart girls and problem solvers, we used the library to research how the best to do it. We saw recommendations for using light material. Nancy's mother threw in an old and ugly chiffon dress that we cut up and designed our kite. And to our delight, on a very windy day, our kite soared higher above all the rest and we got our A's. I think back then this shows that I was a problem solver and into research early on and always loved the library. At NSA, I started off as an applications programmer. Actually, I was in our data systems intern program, and a lot of our queens were in intern programs at NSA. As an application programmer, you got to work with users to define the problems. Then you would use programming languages. Today, it might be Python, Ruby, C++, or Java, but we used something called Fortran, PL1, and assembly language for specific programming. We had plastic templates, and this actually is a copy of my template that I've kept for 50 years to map out our programs. I had a boss, Vince, who always told us that we had the best and most interesting job in the whole world, and the fact we got paid to do it was a bonus. And on many days, I agreed with that. System programmers, and then I moved from applications to systems programming. That involved programming an assembly language and the very basics of a computer. We maintained very large UNIVAC 1100 series systems. And every time an operating system would come out, we'd have to put like 10,000 lines of our own code into the operating system to support the things that we needed for security and processing. I did everything from doing changes to support the Cyrillic print bar that was printed in Russian, as well as security and accounting. And we used to, in our office, we actually had 4 women systems programmers and 4 men. And we used to have a saying around the office, a couple of sayings. One was a woman's hour is worth 2 man hours, because we could get things done a little faster than the guys. And then there was another saying that our boss would say, if you want a job done and done right, give it to the women, because the women really were very good on getting things done. So one other thing that we would do is when systems would crash, we would have these things called dumps, and we would collect them after we'd get 4 or 5 of them. We sit around a table and have a dump party, and we would do analysis on the dumps, going step by step, register by register, cell by cell, trying to figure out why the systems had crashed. This was kind of an early computer forensics, but we had no tools except our minds. But it was fun, and it was a learning experience. So let's see. I was also a project manager for a big system. It was like the largest system of its time. It was called Preface. And I directed the design and the implementation of this and managed the team. It was an exciting project, and we had like 10 people on the team, and we upgraded all the time sensitive processing. So this was an exciting job to do. The reason why I have the smiley faces here on my slide is because that was about the time that it was introduced, and people would go around taking stickers and putting them all over the office or on computers to, I guess, cheer us up. So I moved on to another job where I actually worked for Dottie Bloom, and I was the editor of the first telecommunications plan. Up until that time, the agency had not done any long-term planning, and it was a massive undertaking. One of the kind of the little sidebars in that was we had to do an inventory of all the programs, of all the systems and equipment that we had. And we used a newfangled technology back then. It was called barcoding. And we talked to Kroger, who had just been working with some handheld devices where they were able to optically read the barcodes and put the results on a mag card. So we developed a system where we could go and slap barcodes and everything, and we could record it and say where they were. So this helped us understand what we're doing. So that's kind of what my little story is about. I'm going to turn over to Kathy. If Kathy, can you unmute yourself? I'm going to go to the next slide. Are you there, Kathy?
I'm unmuting. Okay, can you hear me?
Yeah, okay. I'm
Okay.
really glad to see you, Kathy.
Yes. We had kind of a last minute glitch there, and fortunately I was able to get on. So I'm very happy to be participating in the group, and I appreciate the opportunity to come and tell you about my experiences providing computer support at NSA in the 60s, 70s, and 80s. This is just a little bit of background about my preparation for working at NSA. And I'd just like to give you a little more of that so that I can explain to you how I ended up working in this career field. Could you do the next slide? Okay, and this is my backstory. I was born in Connecticut and raised in New England, but when I was a senior in high school, my family moved to Louisiana, which was a little bit of an adjustment for all of us coming down from New England. But anyway, I attended the Louisiana State University, and my goal upon graduating was to be a statistician at the Census Bureau. And it's not surprising that I picked this career because all through school, I really did enjoy math and math-related subjects. And the thing about math that I really liked was if you followed the teacher and you did your homework, when the test came, you just never had to study. You either knew it or you didn't know it, which was not the case in some other courses that I was taking. Anyway, I also enjoyed games that include planning out the next step or the next thing that we were going to do, and anything that had to do with logic related things, I always enjoyed. I also participated in school sports throughout high school. And once I worked for NSA, I worked overseas, 2 separate tours, 3 years each tour. Anyway, could we go to the next slide, please? Okay, so during the college interview process, even though my plan was to go to the Census Bureau and be a statistician, I became aware of NSA and this 3-year intern program that they were offering that would train me to be a computer systems analyst. I was kind of interested in it because it was math-based, so I decided that it was probably a good opportunity, and I signed up for it, even though I don't think I really knew at that time what a computer systems analyst did. But anyway, I moved to Maryland and started my training at NSA. And the first programming language that I learned was Fortran. And with my Fortran training and being a newly minted computer systems intern, I reported to my first office. And that's when I began to be introduced to the world of computers at NSA. And like Eileen, the first system I was working on was a UNIVAC 1108. And I went down to take a look at this system, which was in the basement of the building in this big cavernous area. And it was in its own separate room. And the whole room was filled with this computer. The components were just so large. And it's so striking compared to what we deal with today with our smaller systems. But anyway, maybe we could do the next slide, Eileen, and I can show a picture of the system. This is what the system looked like. And you can see it had a large bank of tape drives, and that's where the data was read in. And then there was an operator console and a computer console, and there were several printers attached to it. Now, my job was to take my Fortran programs, which were in these big metal trays, and the program was typed up on these hollerith cards, these sort of like key punch cards. And anyway, we would trek them down to the computer room, where the program was run, the computer operators would take care of it. And then my job was to come down, and the printers were all covered by these black cloths because everything was very secure at that time. So I, took the black cloth off and pulled out my printout and took it back up to my office, and I would review it for anomalies. And then if there were anomalies or errors in the data, I would make adjustments to the program, and then I would take it back down for another run. Now, in those days, we were lucky to get 2 runs a day. So you really had to be kind of careful about making these changes or updates, because you didn't want to waste a run by making, sort of a stupid error. So anyway, we would work very diligently at preparing our changes and taking them down. So I did this work for several months, and then I started to get ready to move on to my next intern assignment. And I have to say, I was kind of looking forward to it. I had spent a lot of time reviewing a lot of zeros and ones. And even though it was interesting, I kind of thought it's time to move on and do something else. But several years later, I came across a report that talked about the data that we processed on that UNIVAC 1108, which was cryptanalytic data, and the importance of that data to national security. So I was very happy to see that my contribution made a difference. In fact, I really think that was probably some of the most important work I did during my whole career at NSA. But anyway, I was happy to accept the challenge, and then I moved on to my next intern assignment. So Eileen, maybe you can do the next slide. Okay, so in the early 1970s, many companies were introducing new large mainframe computers and also new programming languages. So the system that I worked on, or the systems, were the IBM series, IBM 360 and 370s. And to program on those computers, I used assembly language coding. Now, assembly language coding, programmers either liked it or they didn't like it, because I liked it because it was efficient to use, and but it wasn't. It was more difficult to learn, and also documentation could be a problem with this language. And we needed to provide documentation because if we moved on, someone else was maintaining our programs, they would need to have that guidance to help them out. Also at this time, the software companies were producing these new programming languages. And the languages were kind of tailored. Some were for scientific applications, and some were for more business applications. And I think the whole payroll system, at NSA at that time was done using COBOL programming. But anyway, the languages I used when I was doing this programming included PL1 and COBOL. Now also at this time, sort of towards the 1980s, a little bit later, the software companies were beginning to produce these software packages. It would allow you to do applications that were relatively frequently used in the business world, such as specialized reports or statistics or payroll or project management. Anyway, now at this time at NSA, almost all the software was custom built and built by in-house programmers or else companies that were hired by NSA to do private development. So the software was very tailored to the particular requirements that the analysts had. And when this new off-the-shelf software came along, it really wasn't quite as adaptable as the custom-built software at the agency. But anyway, the managers kind of liked it. It saved a lot of time using these packages, and also it was a lot less costly than custom building every piece of software that we needed. So anyway, even though there was this pushback from the analysts initially, the software became more adaptable as the software companies became more familiar with it and what the needs of the customers were. And so it became much more readily used. And the other thing about it was initially you couldn't really introduce these packages unless you got them identified kind of early in the program development cycle. So as time went on and they became more available and more popular, the planning efforts were broadened to include the use of these software packages. And I don't think at the time we really realized, how important these applications were going to be throughout the years. And now you can see years later, we have stores that have all software applications that you can just buy for a very little bit of money. So it was a huge step toward the modernization of the computer systems. Anyway, I guess we can move on to the next slide. But these were just a few examples of the kind of work that a computer programmer did when starting a career in information technology. And this background and training that I got early on in my career really laid the groundwork for me to be able to expand into a variety of different areas through the many years that I worked at this job. So over the years, I filled positions including systems analysis, system design, systems architecture, systems engineering, project management, and management positions. So it was very helpful to have this background. But I also felt that the career area was just filled with opportunities, and there was tremendous change going on all the time. So it's always very interesting doing work in this area. But I guess if I were talking to somebody who would be interested in maybe thinking about pursuing a career in information technology, here's some of the steps that I would recommend. Certainly complete math in high school through algebra and calculus if it's available, and complete a high school college prep curriculum, because that provides a lot of additional opportunities for further training at the college level. Now, as Eileen was saying, when we went through college, certainly the college I went to, there was no such thing as a computer science major. So now you can major not only in computer science, but you can major in computer applications or computer management or a variety of different career areas. Anyway, I would suggest attending locally sponsored activities that assist you in understanding what's involved in computer science, what's involved in doing programming, so you could get an idea, whether some of these areas would be of interest, including the computer programming as well as the other STEM activities. Now, certainly today, even though the issues are different, the challenges are different, it's all really still there. The research is just starting in a lot of different areas, such as cyber security. There's always something just around the corner. In fact, I kind of would like to start over and pick a particular area where a lot of research is needed and just start over and pursue something different, such as cybersecurity, because I just don't see this career area ending anytime soon. Anyway, thank you for listening to my stories, and I'm now going to turn it back over to Eileen.
Okay, well, I think that's a good lead in to Laura, who has been really active in the cybersecurity and the STEM area. Laura, thank you for joining us today.
Well, thank you very much. And I'm really excited to be here. And I see so many of my friends and colleagues out there listening in today. That's really great to see them out there. So my story, I grew up for the most part in Baltimore. So I'm pretty local to the area. Graduated from Virginia Tech in 1984 with a degree in electrical engineering, and then went on to complete my master's in electrical engineering as well while I was working full time. I started my career at NSA as a cooperative education student in 1981, and then spent 37 years with the National Security Agency. Next slide. So my story and why NSA? Well, my father was a career NSA employee. And as a result, we knew that he traveled a lot. We had no idea what he did. No idea. We just know he was out and about and doing all kinds of fun things. He was an engineer. He's a civil engineer. We got a little closer to understanding it. We moved to Germany when I was 11 years old. So we moved to Germany, to Bad Aibling, which was one of NSA's big listening posts at the time. And so we got more involved with the NSA family because we were living in an NSA bubble, more or less. Then you would ask, well, what are those big golf balls out in the field there? What is that about? Of course, we knew they were antennas, but really nothing else about that. When I got back, we moved back from Germany when I was going into junior high school at the time. That's when I figured out that I really, really loved math and science. Didn't know that before, but it's like, I'm pretty good at this. I should really continue to look into this. As I went into high school, I had a physics teacher who really pushed hard on going into engineering. You need to go into engineering. He really pushed a lot of the girls in our high school to do that, which was great at the time because not many women went into engineering. Of course, my father was also a big influence and really pushed as well. Go ahead, you should really look into being an engineer. And, looking back at the time, I didn't really have any other friends whose father were pushing them into engineering. I didn't think much of it at the time. But hey, that's probably a really big deal that was a big influence for me. My physics teacher also talked a lot about cooperative education programs, and that's something that he really recommended, especially if you didn't know what you were getting into. So basically you could learn on the job while you're in college and figure out, if this is something that was really for you. So anyway, that was part of my selection process for going to school. I ended up as a co-op at NSA. One, they have a great co-op program. So they have opportunities for you to move from, while you're in college, take positions in different organizations, different missions to really learn what the technical jobs were at NSA. The other reason was I didn't have a car and I needed a ride to work. And then I had dad. So dad could take me to work. So that worked out pretty well too. Next slide. So as I said, the first 3 years were in the co-op program. I had multiple jobs in software development, hardware development, and even some technical analysis. I figured out what I liked and what I didn't like. I know this is about the queens of code. I was never really a software person. I really loved hardware development. So let's think of it as I was a coder because I was programming those chips that were going into the hardware systems that I was designing. I spent the first 10 years of my career in the weapons and space community. That mission. And that meant that I was developing systems to process foreign instrumentation signals, or telemetry signals is what you might think of it as. And basically you have a missile that's under test by some foreign adversary, and they have it so it emanates signals so they can understand the capabilities of the missile, where it's doing well, where it's not. That's really valuable information to have. So I was basically building systems to process that so we could have an understanding of what they were doing. It was during this time that I also got to provide support to the Strategic Arms Reduction Treaty that was going on and was in development, and it was a great way to see diplomacy in action because I was kind of on the front lines of it, and during that I was able to spend some time developing a special processing system in support of that mission. This is all leading me to the signals analysis field, where I really spent the bulk of my career and just loved it. And signals analysis is about, understanding, taking apart signals and understanding how they're constructed, and then how we can process them as a result. So you have to do the analysis first and then understand what needs to be done to process it. After spending 10 years in that weapons and space community, I eventually moved over to NSA's larger communications intelligence mission, or COMET mission, which is all under signals intelligence. But I still worked in signals analysis for a number of years after that, but just moved to a different mission set. Okay, next slide. So as it turns out, I was a good engineer. I wasn't a great engineer. There are people who were far more skilled as an engineer than me. But what I did figure out was that I was really good at bringing people together to solve problems, bringing technical folks together to understand the problem and solve it. And I think some of my supervisors saw that in me as well. And they were, said, hey, why don't you become a team chief? And why don't you move up to other jobs in leadership? So soon, originally when I first started, I could work as an engineer. I was still building systems and as a team chief. But then as I moved up, I had to kind of give up. I had to choose. Am I going to be a technical person, or am I going to be a leader, in leadership? I chose leadership. As I said, I was better at that than as an engineer. And that's where I started working my way up through the ranks, always leading technical organizations. I don't think there was a job I had that wasn't a technical organization. But I moved from, a team of 5 or 6 to eventually leading a team of, an organization of 1,000 people distributed across the world in the enterprise. So, it kind of took steps to get there, but anyway, made my way up the ranks. I did have the opportunity, besides working on the signals intelligence side, I did have an opportunity to work in the information assurance, or what we would now call cybersecurity part of the mission. And that was really important because not only did it expand my network, but it really set me up for really understanding the cybersecurity mission, which is so absolutely critical today and affects my work that I do today, which I'll get to later. I became a senior executive in 2001. And with that, I found myself at the CIA. So I took a 3-year tour there, working on a joint NSA CIA mission. And that was probably the most interesting job I had during this time. I got to learn a whole new culture, and I got to see NSA in a different way. It's one thing to work in NSA and understand it, but to see how your agency operates from another agency is kind of interesting. You see the really good stuff we do, and sometimes you see the not so good stuff. But anyway, it was just a fascinating time, and I was able to work with a world-class leader who I learned a tremendous amount from. So he's a legend of the CIA. It was just such a delight to work for him. The other thing that I did, and as a leader, I became the first woman and the deputy chief level of our large cryptanalysis organization. And I didn't think anything of it at the time. First of all, I was an engineer going in there, so that was scary to the cryptanalysis community, having an engineer there. Oh no! But I was the first woman, and I didn't realize. It didn't even occur to me until one of the people said, "We're all watching you. You're the first." I was like, "Oh wow, never even considered that." So it was a wonderful assignment for me. The other things that I did that were interesting is I got to participate in some special activities and special projects. One of which was when the EP3 went down in Hainan Island in 2001, I was assigned to a team to evaluate that, to understand the damage, determine the damage that had been done through that. In doing that, we wrote a report. It was fascinating because I got to work with the Navy and I got to meet my mentor. And the other thing that I did was that I was, because of my expertise in doing this, when the Snowden affair took place, a number of years later, I was called upon to lead the internal NSA work to figure out the same type of thing. What could he have taken and what kind of damage had happened as a result. So that was fascinating. Hard work. Next slide. So my advice for students or for students and anybody seeking a STEM career is, as I think Kathy said the same thing, take the hard courses. Find those really hard courses. You may not get an A, it's okay. But that background is so important. I remember I took calculus in high school, and then when I went into college, man, I breezed through it. It was easy. And so I thought I had a great calculus teacher in high school, and that helped. Gain experience. Look for every internship you can have. I do a lot of review of scholarships now, and high school students have such wonderful opportunities for internships, technical internships in companies and government organizations. Take advantage of those opportunities, or find a cooperative education program. Find a mentor. For me, as a woman at NSA, going up through the senior ranks, there were very few women who were in the senior ranks. And I kept wanting to find that mentor who would be somebody like me, married with children as a senior. It was really hard to find that person. I remember the person who was helping me do it said, you now have to be that woman since you had such a hard time finding the mentor. But I did end up with a great mentor, and who I met through my EP3 experience. And he still works with me today. Take the hard assignment. Taking that job at the CIA was a commute. I had to do combat driving for 3 years. but it was, it's a 50-mile commute from Suburban Park to Langley. But you know what? It was the best experience. And I just learned a tremendous amount about our mission and other intelligence community missions. And the other thing I always say, and this is especially true for women, is find your voice. Find that way to, even when it's being dominated. So many times you sit in a room and as a woman, it's really hard to speak up and say, hey, I have something to say, but you have to put yourself out there. And I tell young women this all the time. I know it's uncomfortable, but do it. Say, if they're going around and you're getting ignored, you stop the meeting and say, I have something to say. And it's really important to do that. Okay, next slide. The epilogue, I guess, to this is my next phase of the career. And this is, it's so, and I want the opportunity to be able to talk about that. I was given the opportunity to become the first chief executive officer of the National Cryptologic Foundation. At the time, it was the National Cryptologic Museum Foundation, but we changed the name in the last year. And it's a tremendous opportunity. I didn't know what I was getting into, but I've learned a lot. The mission of the NCF is to educate the public and to bring along the next generation of students into STEM and cyber-related careers. So that's the primary, we work hard at doing that every day. The next is to stimulate and innovate. We use innovate a lot now too, public engagement, and we want to serve as a venue for having some of those discussions that between the public and private sector about things like privacy, about NSA's mission and doing things like that. We have a newly signed memorandum of agreement with the National Security Agency, and they're looking for us to be that private partner for their public engagement. And finally, of course, commemorate. And this is where a lot of our museum work goes on. And we want to commemorate and celebrate the work that has been done by those who went before us. That means support through the museum, but doing other things as well to support the mission. Really exciting next phase of my career. And we have so much more to do. That's my story.
Okay, thank you so much, Kathy and Laura. That was wonderful. And, the Queens of Code are really dedicated to the work that you're doing in the National Cryptologic Foundation. And, when we do speaking engagements, we want to, make sure that whatever we earn and things like go to that and support the STEM activities. So we think they're doing great things there, and we want to help in any way we can. Just to end this up, I just want to kind of reiterate what we're talking about with careers in cybersecurity and STEM. There's so many opportunities for students to think about this. There are millions of openings right now, and they predict this to be so for the next 10 years or so. So there's plenty of time to get in on this activity. Let's see. How you can prepare. We talked about taking the hard courses in math. Don't use the excuse about math anxiety that, you can do it, you can try, and, get help if you need help, but don't just say you can't do it. Give it a try. Look at, there are a lot of new things online, like coding and computer classes, both at school and online. The activities, even the Scouts, the Boy Scouts and Girl Scouts now have cyber badges, and they have hackathons where you can, try your skills. So those are some of the things. And also we're on social media, and we have a website. So you can follow us on Facebook at Queens of Code, or check out our website. And we're starting to tweet a little bit too. We're getting into that. So I think that's it for our formal question. If they, Diana, did you want to talk about the questions in the?
Yes. Thank you again, Eileen, and to Kathy and Laura. You definitely are the Queens of Code. There were some things I learned about you all that I hadn't heard before. So we're excited that the Maryland Women's Heritage Center now has heard more of your stories as part of her story. The other thing I wanted to mention for the attendees is that this was recorded And so in your email, when I get it back from the cloud or wherever it comes from later, I'll put it out there on the email. So I know there were some folks that were not able to attend today. And I wanted to thank the panel today because they provided their stories for free. And also Eileen mentioned something they had done before with the foundation. And I wanted to thank those of you that made a donation. And that donation will be shared with the National Cryptologic Foundation and with the Maryland Women's Heritage Center to continue our work and exhibits as well. So with that, there is a question I'm seeing in the chat box. And the question is, there are moves to legislate backdoors in encryption. Is this a good idea? So if you want to respond to that, someone? I don't know if that's a Laura question or what.
I don't know if we're going to be responding to some of the policy things like that. It's up to you, Laura, if you want to.
I probably wouldn't respond to policy things either to this. I just know, all I will say is there's risk, there's benefits and risk, right? And, if you put a back door in, that means there's a back door and somebody else can find your back door. So you got to weigh it. But I'm not going to get into, stating policy or anything like that. So
we'll leave that to legislators.
Right. Well, and that is true. Today was all about you all and the Queens and their stories at NSA and obviously now the CIA as well. That's the only question that's in the chat box right now, although I invited anyone to please have something in the chat box. If there is another question you would like to ask our guest today. If not, we'll give it a couple more minutes. And I don't know if any of the Queens had any final comments that they didn't have a chance to do since we have a minute or two left.
Well, I will say that the Cryptologic Museum has done some interviews with 6 of our Queens, is putting together a short film, and they're going to be doing, when the museum opens in the spring or early summer, they're going to be doing an exhibit about us. So we're very excited about that. So hopefully you'll be able to stop by and get some more in-depth information.
Great. And we're also seeing a few more questions come in. So let's get to those. And I've also gotten quite a few thank yous. So I'm sure that's a standard response. So thank you again. And David's asking that he had heard about PL1 in the 70s. What was the language like?
You need to, Kathy, you need to unmute yourself. There you go.
There. Yes. PL1 was introduced in the 1970s, and it was sort of a break away from other languages that were more close to the bone, I guess we used to call it, very efficient and had limited amount of code. PL1 was one language that it created a lot of additional code. Like you would put your you'd put your code in the system, and then PL1 would build on that. For example, it would already automatically generate documentation associated with your code. So it was a very useful new language to use. The only issue that I really heard about was it was very bulky. It just generated, huge program decks. And at that time, we didn't really have much online capability to generate code. So other than the fact that it was what I would call kind of a bulky language, in that it did provide a lot of additional information when you did your coding. But the information, it was useful but even though that was one thing that I understood people kind of had a problem with. But other than that, it was just as good as any other language. And it was very versatile. It could be used for a variety of different systems. And we used it to build a large system that was used overseas. So we found it very useful. And the documentation was easy.
Good. Thank you. And we have another question from Lisa. How did you deal with a bias against your being at the agency?
Okay. One of the things when we were doing the Queens of Code project, we had our women fill out a pretty extensive questionnaire. And I did want to know how people felt about their career and whether they were, treated differently because they were a woman. And we did get some responses to that. Some people did have early on, especially in the like 60s and early 70s, something that Nancy Welker called mid-century gender bias, because sometimes the women would, the men would get like promoted over the women, even though the women were just as or more qualified. But there was actually a class action lawsuit in the early 70s. And one of the things that came out of that was that that all promotion boards would have a woman and a minority rep on the promotion boards, which was something new, and that they would provide statistics about how the agency was doing. And those two things really made a difference going on. But most women felt, a lot of, at least from the surveys that I took, that they were treated well, and they were respected, and they were encouraged. And we were at an agency where it took a lot of investment even to get us hired, because you had to pass security clearances, and then they had to train you for about 3 years to learn the intelligence business. So it was certainly to their advantage that they keep all the good people that they could. So I think people had a lot of opportunities to move into management or to take on big projects. And it was a good place to work. It wasn't perfect, but I think people felt that it was a very good. And also, most of our women had 30, 40, 50-year careers there. So I think that says a lot too.
Right. Thank you. There's another question asking if either of the organizations offer scholarships or training for students.
I'll take that one. I think something that's not just that NSA offers. This is a national offering. It's called scholarships for service. Sorry, SFS. Sometimes it's referred to as Cyber Corps. This is something that students from across the nation can apply for. There are, lots of money in this, where they can apply for a. It's usually during not in your freshman year, but it'd be your sophomore through senior year. You can apply for a scholarship, and you have to then just give back a couple of years of service to a public institution, like a federal agency. But I think you can even go into a state government or something like that as well. It is a tremendous program that I think so few people know about, and that's really a way to get people to come into the national security arena and also pay for their education. Of course, the other one that NSA has is the Stokes Scholarship. So those are really prestigious scholarships where we go out and we try to bring in the best and brightest, and really pushing to bring our underserved communities to the table for that. And that is a full ride for 4 years with a stipend as well. Very competitive, but we've had some great graduates that come out of that program.
Thank you. Kaylin has a question. And what are your ideas for helping narrow the disparities among African Americans in STEM?
I think early, I've been doing some research in this too. And I think early on, in the 50s and 60s at NSA particularly, that the agency and most government agencies did not have a real good record with, with opportunities, although there certainly were some women and men of color at NSA. But about in the 80s, we had a really wonderful person who was head of EEO in the women's program. Her name was Minnie Kinney. And Minnie Kinney spent time working with some of the legislators, and they set up a special program that went to the historically Black colleges and offered scholarships and really worked with students there to get them on the track so they would be competitive for those STEM type jobs. And they really made, in the 80s and 90s, at least when I was there, and I did some stuff in recruiting too, the agency really made a big effort and saw some improvements, did statistics too, because they had to go back and report to Congress how they were doing. So, it's still, I think it's still a one-on-one thing, getting students knowing that they can do it, having them have opportunities, programs that maybe offer mentorship while they're in college to help them get into the right courses. but we're hoping that our stories will reach them too. And in our Queens of Code, there are several women of color who we have been able to get their oral histories and tell their stories too. So I think that's encouraging.
One of the things I can mention, I think I mentioned earlier that we have a portable STEM exhibit of women, and that's fairly diverse. And we've taken that to schools and other programs. And we've also worked with the Applied Physics Lab when they were doing Girl Power in person. And that was, again, for hands-on experiences. And many of the companies in this area and agencies brought young women and engineers as role models too, so that although the Queens of Code have some fabulous stories historically, we also know that young women like to see younger people in those roles today. So there's some things that are going on in the community as well. I want to take just a couple more questions here. I know we started a smidge late. And I think Amy is asking when you realized that you were doing what you were doing was something future generations of women could benefit from.
Well, the project, I mean, I knew that when we were back in the 70s, when we were working with all the greatest and latest technology, that we were doing something really special, and we were pioneers back then. But we really, because of the security things that we had talked about, we really couldn't tell our stories. But it was just in the last 2 or 3 years that I guess I realized that how little there was out there, and that if I could tell our stories, it would be motivating for students to hear about it. So it's been the last 2 or 3 years that I've seen that, like Liza Mundy and the wonderful Hidden Figures movie that came out. So those two are motivating me to say, let's pull this together and get everybody's stories out there. So
good. Betty's asking if you know what's the percentage of women today versus the 10% in the early days. If you have an idea.
Oh, at NSA,
yeah.
I don't know NSA, but in the workforce there's less than 20% of women who are getting like computer science related degrees. So that's a low number, but they are working. A lot of the universities are working with having programs to encourage more women. But yeah, that's an area that really needs some work.
Right.
I don't know what NSA's record is right now.
I'm sure it's posted online somewhere too, but if we find that, we'll share that with you as well. And there was an interesting comment from Ellen in that she worked for the Navy supporting NSA in the building of the hardware. Weren't many women in that. It was an interesting endeavor. So I'm sure she has some stories to share as well. And Susan is also mentioning the AUW, which is the Association of University Women. They're also a valuable tool for students pursuing STEM education. Thank you, Susan, for reminding us of AUW. And there were many, 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 many thank you comments that were here in the chat box. So I want to say what a difference it's made. We're so glad that we have a recording of this. We had hoped to have more teachers that were available to join, but again, I'll share it to our contacts at the State Department of Education. And now that we have the recording as well. So with that, the Queen's.
Yeah, let me mention one more thing. This program was being simulcast by the Internet Society, and they're going to make an archive version available on their website, so that if teachers want to use it in their classroom, or students just want to take it as an after assignment and write a report on it or something like that, it should be available.
That will be great. All right, and to everyone that joined us today, I want to say thank you so much for coming. I'll be honest, I was a little worried today because the weather and power failures and ice storms, but Mother Nature was at least partially smiling on us today. And I wanted to thank again the Queens of Code for being with us and for whatever we do together in the future. And for the rest of you, stay well, and we'll see you on one of our next events. Have a good evening.
Thank you all for coming.
If the Queens would stay on for a minute.